Good morning and welcome to Reduce Costs by Assembling to a Function. My name is Stephanie Price, Senior Applications Engineer here at Promess Incorporated. And today I have with me Scott Laske.
Hi, my name is Scott Laske. I'm also a Senior Applications Engineer here at Promess. I've been with Promess about 16 years and been in our engineering team for about the last 10. So today, as Stephanie alluded, we're talking about assembling to a function and basically what exactly goes into that. And would you need to do that for your application, and when does it make sense to do that?
I think that's a really good question, right? A lot of people out there are probably wondering, do I need to assemble my part to a function? And how you can determine that is if your part functionality is determined by how it is assembled, then you should really look at assembling to a function. And that's what we're talking about. We're not talking like a mathematical function. We're talking about assembling to the functionality of the part.
Exactly. And so, the main reason for doing this is you want high quality in your parts. Any application, any product that's going to go out to a customer end user, you want it to function and work as described or advertised. So, really that comes down to the quality. So you want to make a viable, good quality product.
Right. A lot of times it was done by either precise tooling, fixturing, even to the parts themselves being done to a very precise measurement. And that gets very costly. It scales up very quickly in the manufacturing environment.
So like Stephanie said, it's, if you have several components that all get assembled together to make your product or part, controlling the tolerance of each subcomponent can get very costly. And even if you do control the tolerance and they have really, high quality subcomponents that are going to be used to install in your part, it doesn't still guarantee that the overall quality and the functionality of that part is going to be perfect.
Another issue that customers run into is that if you're assembling in one station and then you are testing the quality in a completely other station, what you're using to test the quality is not necessarily the same components that you were using to assemble. So now you run into an issue of, is the issue with the assembly process, or is it an issue with how we're testing the quality of the part to begin with?
And so that comes back to cost again too. So if you're having now one station to assemble a part and another station to gauge it and test it, now you're basically using two stations and it's additional cost for, to make that product.
Right.
And being able to do all of that in one cell, test, assemble, and as we're assembling it, being able to test its functionality, you're ensuring that is going to be a viable, good quality product.
So let's talk a little bit about the different applications that we can do this process with. First, I think one of a really basic tool to think of is a pair of pliers. I know just recently we moved and we had to go out and buy new pliers because we couldn't find where we packed the toolbox in all the boxes. And I actually had to give my husband the pair of pliers. They were completely useless to me because they were just too stiff, right? And it was very difficult for me to use. So I had to give them to him. And basically to me, they were not worth my money. To solve that problem, our customer used this process. So what we did was we had our two halves of the pliers, and then there's this little rivet right here. We used our press, which is an EMAP, an electromechanical assembly press. We used our rotational axes, a Torque Pro, and we pressed this rivet to a known dimension and then actuated the two halves with the Torque Pro to understand where the torque was, right? Was it too loose? Was it too tight? Most of the time it's a little bit, the torque itself is a little bit less than what they want to see. And then we come down to a relative amount based off of the torque here so that each and every time the pliers are assembled, it's assembled so that it has the same torque and feel regardless of the part.
So in this application, it's a two-axis system. So you have the press and the Torque Pro all being fed back to our controller. So we get the force feedback from the torque system and the press system. So it doesn't matter, if you have a large variation in rivets, from part to part, rivet height could vary, or the structure, or same thing with the bore, or even the tolerances on each half. There could be a lot of variation in every single part that's made, and that really doesn't matter or affect the overall process now, because we're pressing this rivet and actuating the part and testing the force it takes to open and close, and verifying that rivet height is going to be pressed to the same or the perfect dimension for the tolerance of all the components used.
also, the customer no longer had to test the quality of these parts offline because we gave them a printout of the force and the torque that it took to assemble the product during the process. So all of their quality paperwork that they needed was kept right there on the station.
So yeah, that goes to a good point. So now we eliminated costs with this customer because we do everything in one station versus having an assembly station and then a test station. And, you know, not only with the cost savings and everything, but being able to take, if whatever application you're working on, you know, you have an offline gauge station or another station that just tests the functionality of the part after it's assembled, you know, that's when you really kind of look into, well, can we test it as we're actually assembling it? Can we take that gauging or whatever the tooling is that might use in that application and use it while the part is being pressed?
Right.
So, yeah.
And this, I mean, we've done this with many different applications. I think we're going to talk about the next one.
So one that came in particular was a ball joint, or in this case, tie rod. So our customer came to us with this application, and basically you have the ball cup and the ball joint here that gets fed into the component or housing, and then it gets crimped into being put in place. And depending on the amount of the crimp force, it's, you know, will affect the overall functionality of the ball joint itself. So for this application, typically the part was done, crimped to just some known dimension, and then tested later on down the line. And, you know, you could have some issues with the ball joint being too tight or too loose. So what the customer came to us for this application, and what we ended up doing was basically using another 2-axis system similar to the Torque Pro. We have a press that comes down and forms the roll crimp on the opposite side of the ball joint, and then a torque system that actuates the joint. And so there are a couple different things we're looking for here. Once we crimp it, we would first come down and crimp to a known height or dimension, and then actuate the joint. Typically, you would break it in and wear it in, and we'd be looking for a few different things. We want to measure the amount of torque it takes to actuate the joint from one side to the other, the overall torque it takes to move it, and then the amount of travel it's doing. So we're looking at the angle, the rotation, and the torque, and we're looking at all these things after it's gotten crimped. So if it's too loose, we would then come down and crimp an additional amount, and then keep actuating this so that we know that that crimp is going to be the perfect size or force crimp for this for that ball joint.
Yeah, that's a good point. I mean, it sounds very similar, right? But we do this a lot in so many different applications. We do the process, we test, we measure, and then we come down and we do more of the process. But we can do it with more than just having a 2-axis system. We can also do it taking in several different sensors and having either just a Torque Pro or just an EMAP. For instance, with the pressure relief valve, we were assembling a pressure relief valve, and in order to make sure that it was properly assembled, it needed to see 1.2 liters per minute through the valve. And what we did is we had a flow meter attached to the end of our EMAP. And as we were assembling the valve, we were monitoring the flow rate going through the valve. And once we saw 1.2 liters per minute going through as the flow rate, then we stopped the assembly. So our press actually continued to move until it saw that flow rate, and then stopped the assembly and was able to retract. And we knew it was assembled properly because we're using a closed loop system, right? We're taking that flow meter into our controller along with all the other controls that we have going on in the system. And that's how we were able to accomplish that. So
that's a very good point. It's, you know, you don't always need a 2-axis system or multiple moving components at this point. You know, we're assembling it and testing it exactly how it's going to be used in the field, feeding that flow rate through it, and then monitoring that input signal to the Promess. So every single valve that's pressed together, it doesn't matter the stack up heights of different components that's used. One component, a pin or whatever it may be longer from part to part than in the next one. So really, you're assembling each valve is going to work exactly identical, no matter how all the subcomponents were made or manufactured.
Well, and also the other thing that I did, it helped our customer increase the throughput, because they were doing everything in the one station and they weren't taking it down to another station down line. So everything was done in that one station, and they actually increased the amount of valves that they made in a day, because they didn't have that extra step that needed to be done with the quality.
And you also think about too, if increased volume, just reducing scrap, that will increase your volume. If you know every part you assemble is going to be correct, and you don't have a 10% scrap rate or whatever it may be, you're increasing your volume, and also, like Stephanie alluded to, alleviating stations, test stations. It's only good things in the end for your customer.
And again, you have that monitoring, right? You have the press distance, you have the flow, so you can see that graph and keep that data for you. And you can also use it to, look at the trends of your process and see what's going on within it. So.
Yeah, and I know a lot of applications too, just by being able to test and the functionality of it is, if you get a bad batch of parts in, and there's a physical component wrong with the parts and you're not able to assemble it. I mean, it's one of those, we can catch issues ahead of time by testing the functionality as you're pressing it. It's not something that can potentially get out into the field later on and then become a failure, which is the worst case scenario for everyone involved, because the customer is going to be unhappy. It's going to come back to whoever made the assembly or whoever,
Yeah, the goal is to never let a bad part go down the line.
Exactly.
Right.
So, another application that I'm sure that we're involved in by testing or assembling to a function that everyone has assumed used at one point or another is a door hinge. So something simple on every vehicle, there's a door hinge. So as you open the door, it takes a certain amount of torque to open that door.
Yep.
And then also the door's not just going to slam back shut once the door's open and you're no longer
holding it. That's a safety issue if it does.
Exactly. So we have a door hinge here. Basically, there's a spring and a nut that run through this hinge to allow the amount of motion and how much torque it takes to actually actuate and turn the door hinge. So in this case, we had a torque pro that was rotating and tightening down the nut. And then we had another torque pro that was attached to the door hinge that was actually actuating and turning it. So as we tighten it down, we were actuating that door hinge and making sure the amount of torque it take to move it and fell within a certain range. And then also the amount of travel that was allowed to the door was properly done. So you never get something that, potentially could go out in the field and swing right open when you try to open it. It takes too little force, or again, just shuts on you without you holding it. Right.
Because that safety issue, especially for fingers. Right?
Yes, exactly.
And the nice thing too is you know the torque that it's taking for this nut as well, because you are using the Torque Pro.
Yeah.
So just to kind of recap everything we've stated, really, when we talk about assembling to a function, we're talking about assembling to the functionality of the part to ensure the quality before it gets downline, to allow you to make your parts faster, find your mistakes faster, and really be able to program and assemble to imprecise part.
Yeah, and it's not you're not able to control the tolerances of every component or subcomponent that gets installed in the product or part. It's you can try your best to have extremely tight tolerances on every individual component, but it's nothing's ever going to be perfect and nothing's ever identical. Right. But by being able to assemble it and to a function, you're kind of ensuring that every part that comes out of the station is going to be identical. And that's the overall goal, is making a very repeatable and identical process so that all the components are going to function the way they were designed to. And, in the end user, the customer, and everyone is going to be happy with the results.
No longer do you have to press and hope or assemble and hope that it's correct. You'll know that right during your process. So.
Yeah. That was always one of the bigger issues is, it should take this much force to assemble this part. And then hopefully later down the line, when we test it, that turns out to be right. So that's not always the case. And, by using this process and being able to test the functionality of it as we're assembling it, it really alleviates so many issues and can be so much beneficial to everyone involved.
Yes. And no longer do you have to worry about trying to have very precise parts and tooling.
Yeah. And one other application that just kind of comes to mind is just even bending and straightening applications for saw blades and various other types of medical devices where there has to be a certain radius or a certain flatness on the component or part.
Yep.
And being able to control that when it can be very difficult. So we sometimes would have a multi-axis system or maybe multiple probes that are all measuring a part, and we come down, we can press it, and then measure the actual probes, measure the flatness or straightness of that part, and then determine if an additional amount of force or press was necessary or needed for the that application. So it's not only just assembling, it can be straightening, bending, torquing, and it's there's all sorts of various applications that you can do this with, but it's just whatever makes the most sense for your application.
All right. So it looks like we have a few questions from the people who are watching today. So let's take the first one. How do I find out how much force my application takes?
Well, one of the first things we recommend is utilizing our PDC, or Process Development Center, that we here have at Promess. We basically have a lab set up with a wide range of systems of different sizes, torque systems and press systems. And if you do have a part or component, and maybe it's something you've been done for a long time manually or with hydraulic presses or whatever it may be, and you want to know the actual force it takes to assemble that, is you can send your parts to Promess, or even just we're welcome to have you come and join us here at Promess, and then we can spend a day in our lab basically assembling your part, developing a process for it, and really finding out all the information and data that we can generate to what it takes to assemble your part and how to do it properly. So this is something we do free of charge here at Promess, and typically I'm normally involved, or maybe another application engineer might be, and we'd love to have you come down and visit us at our headquarters here in Brighton, Michigan, and we can run some parts, assemble them, and then send you some data back. So get a better overall feel for the application before we just sell you a press.
Yeah, because a lot of people don't necessarily know, if you've never used a servo, or maybe you don't have the monitoring in your servo system to know exactly what the force you're using is. And it's very helpful to be able to prove out that process ahead of time.
Exactly.
All right. Can I adjust a part for not making, can I fail a part for not making cycle time even if it's still adjusting? Yes. So you can put in just qualifications if you don't want it to try like 3 times and you can't get the part to assemble properly after 3 times of going through the steps of testing, measuring, testing, and assembling. Then you can go ahead and most certainly jump out of the program. Our program is very easy to use. It's step-based, and you can just jump right out of that and go to the end and fail the part for that.
That makes a very good point. It's, especially it brings to mind of this application. When we come down and we press on this rivet, we back the press off and then test the functionality of it, and then determine if we need additional amount of press is needed, or additional amount of force to apply to the rivet is needed.
Right.
And then we would set counters up or whatever it may be to after 3 or 4 tries, let's reject this part if something isn't right with one of the components or something.
Right, because the whole idea is to help reduce money, and you're not going to do that if you're sitting in a loop time after time again trying to get a perfect part.
Exactly. What's a typical failure rate for pressing to a function? Again, typically it would be very low. It's normally it's almost 0. I mean, depending on the components. Every once in a while, there will be potentially something wrong with one of the components. A giant oversized hole. No matter how far you crimp this rivet, it's never going to hold the appropriate amount of torque. But really, it's reducing that amount of scrap, and it's greatly reducing the amount of scrap and everything utilized, so that failure rate will be close to 0, if not 0. But yes, there can potentially still be failure rates. Everything's not going to be perfect all the time, but if we catch a failure now, it's 10 times, it's 1,000,000 times better than catching it later down the line, or in the end vehicle or whatever.
Right, or even when you catch it when it's a smaller part of the component as opposed to already assembled, and then you're having to scrap or rework a larger component.
Yeah.
So, what is the max torque that can perform? So I think they're trying to find out what maybe the max torque of our Torque Pro is, and our largest Torque Pro that we have is an 11,000 Newton meter torque unit. So we pretty much can handle almost every size of torque that your part needs.
And all the way down to the low end of 1 to 2 Newton meter systems, or we really when you get down to we have standard sizing from 5, 20, 50 Newton meters. Up until the 11,000 that Stephanie alluded to. But really, it's if you do have an application with a very, very light torque load, and maybe certain parts of it are light, certain parts are high, we can add external torque transducers into our system. So again, external load cell or torque transducer that would be applied or mounted in the tooling that would somehow engage the part. Again, that would just be an additional sensor that would get fed back into our controller. And so then when you're pressing or torquing or monitoring the part, you're using our program, you just select which sensor you want to modify, or you want watch or look at during the assembly process to determine if it was good or bad.
Kind of like we did with the pressure valve when we used the flow meter in order to stop the press.
Exactly. So we not, during that application, we look at the force feedback from the press, and we do use that to make sure that the part is good. We probably put some sort of limits on it. It should take a certain amount of force to assemble it, but the main criteria for the test or the assembly is that flow rate. So that's the main thing that we're pressing towards or monitoring during the press.
My part might need 3 or 4 axes of measurement for its function. Is that possible? We do have a multi-axis controller that can take up to 8 axes of motion. So 3 to 4 is well within our ability in the system.
And that's just motion. And that's just motion control, up to 8 sensors.
Right.
So, sensing, as far as if you have an external load cell or digital probe or a flow meter, we can really take almost as many of those as we want. It's what makes the most sense for the application.
Right.
But that is another one that it's, really there's no limitations there as far as the amount of stuff we can measure and systems we can control.
In a multiple component press, so not aligned axes, can you differentiate or see forces and distances for parts that start pressing at different distances, like step-loaded function requirement? So our controller is taking in the distance and the force for each axis, so they don't have to be aligned. They can be oriented any way that's needed for the proper assembly. And
it really it's application based. However, everything needs to be oriented and oriented, or directions, all of our systems.
Right. The sensors come in individually, even though we're taking them all in. So we can define what sensor is going to what press, and we can see the different distances for each one of the presses. So that actually would not be an issue at all.
And we also create different programs or part models for each part model. So if you have variances in heights for different part models or whatever it is, we just would run a different program that would have all those parameters and the criteria for that test kind of already set up and defined. So that wouldn't be any kind of issue for us.
I hope we answered that question, how they were asking it.
Yep.
And the last one is, can we share formulas to calculate interference among axis and hole? Well, we can't necessarily share anything proprietary to our customers. Our application engineers are well versed in setting up different mathematical functions and things that are needed to figure stuff out like that. And our UltraPro software is very powerful in being able to use functions and graph mathematical functions within the software.
And like you said, it's, certain applications, we can't share the exact details of certain formulas and things that we've done on that, but we've been involved in this industry for so long, and we have so many engineers with vast amounts of just experience in different types of applications that typically, for the most part, we've seen a lot of the various applications out there, and we have an idea of already how we do it or how we set it up. So we can share that knowledge. That's why we like people to come in and utilize our PDC. Just so if you're doing a process one way, we can test it and do it that way. And then we might have ideas or suggestions for different ways you can handle that, or maybe different fixturing or tooling. It really just depends on the application and everything. And we'd love to kind of share our expertise with you and just give everyone a better feel about if you're thinking about using Promess for any type of application, that we can not only do it, but it's going to be done in the correct or best way, I guess.
I definitely feel like every single one of us here at Promess, we get the most satisfaction out of working with our customers and helping them achieve their goals. That's pretty much the heart of our team. I just want to thank everybody for joining us this morning. If you have any questions or want more information, feel free to visit our website or give us a call here at the office. Also, there is a handout in the chat that talks a little bit about how assembling to a function, and look for our other webinars on our website. Have a good day.
Thank you.